Let's see how to enter loads on sections in CYPE Connect. To do this, once the node has been created, we select it in the table on the left-hand side of the interface and edit the connection by clicking on the corresponding button at the top. In the Connection pop-up window, if the model of the connection is already complete, we go to the Analysis tab. Then, we click on the Loads option in the top toolbar. In the pop-up window, we define the loads applied on the connection sections. We can also generate these loads automatically via Generate from the BIM model. We can also modify them or enter them manually. In this case, we select each of the sections in the table on the left where their reference is displayed. We must define one of the connection sections as bearing by activating the corresponding checkbox. The bearing section has an external fixity at its end. If this section is continuous, we must indicate whether there is external fixity at the initial end, at the final end, or at both ends of the section by selecting one of the options from the drop-down menu on the right. We are also reminded that it is not necessary to enter the forces on the bearing section since they are obtained by equilibrium. Further on, we select the other sections, and in the Stress Deformed Shape tab, we enter the forces acting on each of them by filling in the cells of the central table. For each load case, we define the axial force, the shear forces in Y and Z, and the bending moments in X, Y, and Z in the indicated units. Right-clicking on cells brings up added features that allow us to copy and paste data directly from spreadsheets. The graph on the right displays the axis criteria corresponding to the types of sections we are working with, which can be non-continuous, as is our case, or continuous, which won't appear in the current example. At the bottom of the table, we type in the distance between the application point of the forces and the theoretical node. This way, we can indicate where we define the forces in each section. If we are entering the forces of the theoretical node, that is, the point of intersection of the section's axes, the distance value must be 0. If we wish to enter the forces of another point, for example, those applied to the face of a column, we must type in a distance value equal to half the width of that column. This distance shall also be read from the BIM model, provided that the structure has been analysed considering the finite dimension of the nodes. In the diagram on the right, it appears as the letter D. In the design model, the program will apply loads at the end of each section to obtain the forces entered at the indicated point. Additionally, if we wish to consider the rotational stiffness, we must activate the corresponding checkbox in the desired sections. Then, in the Rotational Stiffness tab, we can add different node cases, creating a specific list of forces in which the load of the other bars does not affect the design of the rotational stiffness of the connection. At the top, we find tools that allow us to copy, delete, and move the elements in the list. Here, we define the forces applied on the connection section, which we may have generated automatically via Generate from the BIM model. For each load case, we define the axial force, the shear forces in Y and Z, and the bending moments in X, Y, and Z in the indicated units. We can also modify or enter them manually. In order to analyse the rotational stiffness, there must be at least one moment in Y or Z. Again, the graph on the right displays the axis criteria. Underneath, the L length is shown. Further down, in the middle, we indicate the theoretical length of the elastic bar Y and Z. We can also activate the checkbox to use a specific KB factor for this bar. Otherwise, we will use both the KB factor and the KB prime factor entered in the selected standard. On the right-hand side, there is a button with information on the factor KB, which shows a graph of the classification of the connection. Finally, we click Accept.